Welcome to the Marshall Space Flight Center's Avionics Hardware-in-the-Loop test facilities. In this room, we have the System Integration Test Facility known as the SITF, the System Integration Lab known as the SIL, and the two booster rings. In here, we are testing the avionics for the SLS vehicle. Everything in this room is as close to flight as we can make it because we want to test what we fly and fly what we test. What do I mean by that? We have the three rings of the core stage in this room. The three rings are laid out from bottom to top as the forward skirt, the inner tank, and the engine section. Now you probably notice that the vehicle in here is upside down. However, while we are testing, it doesn't know it's flying upside down. We did this because most of the configuration changes are performed on the forward skirt, so we wanted the people working to have their feet firmly on the ground for safety purposes instead of 16 feet in the air. All of the cables on the structure are the same length as what is on the SLS vehicle. We did this so we can check for data drops, noise on the line, and to verify the messages are being passed as quickly as needed. The difference with our vehicle and the real SLS vehicle is that we have added breakout boxes, or bobs, throughout the vehicle. On the back side of the structure, there are gray rectangular boxes with two red lights on them. These are data breakout boxes, or DBOBs. These DBOBs allow us to check the data flowing between the avionics boxes. They also allow us to insert a model in place of an avionics box with this breakpoint and inject a fault because the avionics boxes only work the way they were designed. We do this using two pieces of software developed here at Marshall known as Artemis and Maestro. We use Maestro as the user's interface to set up our test configurations, whether it's an all-digital run or a single avionics box, and the rest models are a full avionics suite. The models of the avionics boxes, as well as models for the flex and bend of the vehicle, the sloshing of the tanks, and all the environments are running in Artemis. We are also testing with the real flight software developed here at Marshall. You can see the three flight computers located on the bottom row with the forward skirt in the middle of the structure. Remember the lithium-ion batteries I mentioned before we entered the lab? Those are the four green boxes that look somewhat like lunch boxes midway up on the vehicle. They have nice red knobs below them so we can safely return the vehicle to ground power and save the batteries when they are in use. In the center of the ring, you can see two black racks and a blue rack. These are emulators from the other centers. The black racks are the Gale racks or the EGS racks. KSC has used these racks to test their pre-launch ground procedures and have successfully powered on our avionics boxes. The blue rack next to the Gale rack is the MPCVE or the Orion emulator. We have been running tests with them and they have watched the data on their screens as well. Our group also builds and sends emulators of everything you see on these structures, including Artemis, Maestro, and Flight Software to other centers. I refer to them as a rocket in a box. Once our emulators are integrated with their hardware thinks it's sitting on the SLS vehicle, and they can test their hardware. Back behind the SITF and the SIL are the two booster rings and their avionics. We are currently integrating with the boosters on SIL and will be commanding and flying with them, which is very exciting. I hope you've enjoyed this tour of the SITF and SIL at Marshall Space Flight Center.